It's so awesome to see so many familiar faces here and some new ones. I'm biased, as I'll say in our closing as well, but we have some wonderful cohort members this year who are definitely representing this space today. So we'll share a little bit more about that opportunity at the end of the day. But Liz and I are here to talk to you about CodeSavvy's CS integration framework. And if you were just in Sarah's session, you'll see there's definitely a need for starting to integrate computer science into the content area classrooms. So we're hoping that we can provide some resources for you to help make this a little bit more possible. So to start, we'll kick off with some introductions. My name is Ashley Getz, and I use she, her pronouns. I work in two spaces. I work at CodeSavvy on Team Educate in a couple different roles, but a lot around PD for educators, including our cohort, and some curriculum work as well that we do with schools. I also am on the curriculum and instruction team at Girls Who Code, focus a little bit more on the curriculum in that space. And I'll pass it to Liz for an introduction as well.
Hi, everyone. My name is Liz Walsh. My pronouns are she, her, and I work at CodeSavvy as an instructional coach. So I work with our school partners to coach individual teachers, provide professional development, and then I also develop curriculum for CodeSavvy. So some of that's integrated, some of it's standalone, but we're really excited to get started to share more about this resource we've been working on for the last couple months.
Great. So to make sure you are in the right spot, I guess as well, before we jump in, please feel free to drop introductions into the chat. We'd love to know who we're talking to today, whether that be grade level you teach, maybe you're a district leader, maybe you're in a community organization, but it's helpful for us to tailor some of our examples to you all as you're here. So thank you so much for choosing our session. We're super excited about what we're going to share with you. So to make sure you're feeling like you're in the right Zoom room here, here's the goals for this session. We're going to start by defining CS integration. It might be familiar to many of you, but if it's not, we're going to give a little bit of a deeper intro here, as we know that this is the direction the state is heading for many wonderful reasons. Then we're going to talk a little bit about the importance of CS integration. And then we're gonna primarily focus this session on the tool that we've created to help both teachers and coaches start integrating more computer science into content area classrooms. And we do plan to kind of end this session as a little bit more of some workspace for you to kind of take this tool and hopefully start thinking about how it might apply in your own context. We definitely want this to feel relevant to you today. So with that being said, we are going to kick off here with what is CS integration. So probably not a great teaching best practice. I have a long definition here to start with, but to kind of ground us as we get started. CS integration in the content area classroom refers to the practice of incorporating concepts and skills from computer science into the teaching and learning of other subject or content areas. So we're not talking here teaching computer science in a computer science specific class. We're actually talking about bringing CS and the skills that are involved with CS into other subject area classrooms like math, ELA, science, physical education, et cetera, et cetera. This could be into any other space. Now you've likely seen, and maybe you haven't, some more general tech integration models, like the two that we offer here. There's many. We've got the TPAC model and the SAMR, if you will. I know people might pronounce this a little bit different, that talk about different depths of integrating technology specifically into content area classrooms. So for example, as we look at the model on the left, this TPAC model, this provides a useful framework for understanding the complex just interplay between technology, pedagogy, and content knowledge, and guides educators to think about this overlap. Where the SAMR model thinks about the different depths of technology integration. So if we look at the bottom of this model, we think about substitution. This is simply the means of just replacing a place where somebody might replace a non-tech solution with technology. So thinking of an example, having students write an essay in Google Docs rather than using pen and paper. So it's more of a surface level, maybe integration of technology. Where if we go all the way to the top of this model, a more in-depth integration might be this idea of redefinition, where teachers are actually creating new and innovative learning experiences for students that previously would not be possible without technology. So tons of examples here, but I'm thinking of using Zoom to set up a call with maybe pen pals across the country, maybe in a different country, where these students could actually work on a project together. We know like traditional pen pals could definitely pass paper messages back and forth, but this actually allows students in different contexts to be collaborative, to learn about different experiences and perspectives as they collaboratively work on something. So we're not here to talk about these two models, but we do want to give some context that these are specific to integrating technology. But we are here to talk to you today and pose a model specific to integrating computer science. So a little bit different here. So in our model, we present a visual here of an iceberg that represents different levels of depth to integration of computer science specifically. And it's important to understand here, to ground ourselves, that computer science can be integrated into curriculum in a number of different levels or depths, kind of whatever word you want to use here. And there's no right or wrong way to integrate it, but understanding these different levels can really help us make intentional decisions as we're planning a lesson or creating something or leading something about exactly what is our goal as we're integrating computer science into our space. What level are we going for and why? So we're going to break down the different levels here with a few examples as well. And please drop questions or comments in the chat as you're going. Perfect. All right. So first up, we have the more, I don't know that shallow is maybe the right word, because this is definitely a great way to integrate, but maybe I don't know, the shallowest, we'll just use that for now, of presenting and sharing. So presenting and sharing knowledge. So as we read in this definition, this level of integration creates a space for students to share knowledge and understanding of their content area skill. So for example, an ELA learning goal with the support of a CS tool or computational concept. So in this place where students are not necessarily learning more about their content area skills, so they're not learning more maybe about the ELA learning goal, maybe they already have that knowledge down, but they're using computer science to share what they know. So we're thinking of like a Q&A game or creating an animation to present a story or a book report that students wrote. They're simply and not so simply conveying information that they know already. So we grabbed a couple examples here. I know I'm definitely a visual learner and it helps me to see this in action. But the first on the left is a program students created in Scratch, where they likely learned already how to translate some of these words from English to Spanish outside of this experience. But they kind of took it a level further here as they went into Scratch to present what they know. So they used computer science to present some of this content area knowledge that they've learned. A wonderful way. Scratch is incredible with animations and interactivity if you haven't used it. On the right, we have a chatbot here. So in this example, students learned about generally what cybersecurity is, and now they're creating a program in Python to demonstrate what they know or to help teach somebody about this content. So again, they've probably learned these content area skills outside of this experience, but they're using this tool to share the knowledge that they know. First level. All right, second level, we would say is illustrating processes or strategies. So we would say this level of integration creates a space for students to engage in some of those computational thinking concepts and approaches like problem solving and collaboration. So students are working through their content area learning goals, but also learning and applying new computer science concepts that are crucial to the field, like problem solving. So for example, they might be collecting and analyzing data. They might be debugging or working through a mistake. If you're a math teacher here in this call, like I know there's been a popular phenomenon of like the best math mistake. That's an example of debugging and problem solving. As we think of a few kind of visual examples of this, thinking about making students learning visible, or the process of their learning visible. So a flow chart can be an incredible example of this. Rather than just asking students to create a game, the teacher in this example actually asked them to create a flow chart first to break down their game. So this process actually allows students to apply decomposition. If you haven't heard that word, the breaking down of a bigger problem, or even pattern recognition. If you look at question 1, 2, or 3, it's pretty clear in this model that there's a similar pattern that's going to be used despite how many questions students are adding to this quiz game here. Another example, we've shared this with our current cohort members. We did this just, I think, last month. Debugging challenges can be such a fun way for students to problem solve, to collaborate, so forth. But the idea here is we've got a goal. When the green flag clicks, we want these 2 sprites to be doing something specific, but they're not doing that right now. So with your peers, with your classmates, go ahead and see if you can find the error and debug this. And our third level of integration, which is integrating concepts. So this level of integration creates a space for students to develop a deeper understanding of both the academic content and the CS content. So students likely in this level of integration are learning new things in both spaces. So a few examples, students might use CS to simulate a process to help them visualize something deeper. They might use CS to explore a skill in maybe a more real world application. A few examples here. In this example, using geometry skills and Python to model the pattern of stars on the American flag. We'll see the highlighted code here. They're using for loops. They're using new skills in Python. So learning things in that space, but also thinking about patterns and shapes and angles that are important to the geometry skills of creating a star. You'll maybe see through some of my examples. In a previous life, I was a math teacher, so I apologize for the math heavy examples, but I tried to sprinkle in a few different things here. Another example here is applying variables to store values in a program. Students use variables all the time in the math classroom, but coding can be a really powerful way to see how variables are working in action. They're actually storing values and they can change in a program. So the application here. And another example here, using Python to help visualize a data set. We think about data science is going to be a huge skill needed for students as they make sense of data around them and they use tools available to them to help make sense of it so that they can act accordingly. So a couple examples here. A lot of me talking, but we'll pause for a second. I'd love for you to think about, there's no right or wrong answers here. Looking at the 2 examples on the screen, and I'll give some context, I'd love for you to take a guess. Example 1, example 2, what level of integration would you imagine these experiences are potentially for students? A little context, the first example is a program in Scratch where students are typing in a temperature in Fahrenheit, and the program is actually computing. There's an algorithm in the program that's computing and changing that degree into Celsius. So that's the first example. The second example is an integration model with poetry. So you'll see here, students are using Python again to create a short little poem that takes input from the user. No right or wrong answers. I actually think we could make a case where these are actually fitting into many different levels. But I would be curious to see what folks think about example 1 and example 2. Yeah, we can think of like what content, we can think of exactly like, is this a present and share knowledge? Is this integrate concepts? Either way is great, but would love for you to take a second to think. I love it. I'm seeing a few different answers in the chat. I see a few people have sent me a private chat, maybe accidentally, with their answers. Definitely feel free to send it to everybody. Okay, love it. Again, just to keep us kind of going with time here, I do think we could make a case for these being at really many different of these levels. I think there's a lot of things going on here. I think for sure, in the first example, I'm seeing some people say, okay, this is math. Some people are saying this is science. For sure. I think that could fit into either content area classroom, and that's a great place to start. I also think we could place this into maybe present and share knowledge, potentially if students already learned how to do this by hand. And then they were moving into, hey, we want to show how a computer can actually do something really quickly for us. And we can use some of these tools to help us speed up a process. But I also could see the first example maybe fitting in integrating concepts, which I see some people have typed in here as well. Maybe they're actually learning the power of variables. They're learning the power of these things for the first time as they're programming their program here. I love it. Yeah, number one also, thank you for pointing that out, Christine, integrates art. You'll see like Scratch is such a visual programming language, and there's definitely some art here. I love it. Perfect. And number two as well, I'm seeing some people are saying ELA for sure, or reading, but definitely more of an arts example in the second one here. And yeah, creating a Mad Libs, exactly. I think same thing here for number two. We could probably put this in a couple different of these integrated levels based on how we're presenting this or based on how we're doing this with students. I do think, as you'll hear through our examples, we can have wonderful ideas, but there's so much importance to the educator just being intentional with the goals of how they're trying to integrate. So that's what we want to plug here next, is just saying either way, the goal here is to get clear about your goals of integration. There's no right or wrong way to do this. All of these levels are great. But by being intentional, we can make really intentional decisions with our students about exactly what we're trying to do here with our goals. And if you were in Sarah's session, we want to just give a quick little plug here because I think this will be really helpful context setting before we dive deeper. But you'll see some of the examples we shared, you might be thinking like, whoa, using Python to like do something with data, that looks really scary and maybe requires a little bit more experience for students or for educators to do something like that. But we kind of want to like back up a little bit and name like, whoa, this does look difficult potentially. But we want to remind us that when we say we're integrating computer science, we aren't just talking about coding. We realize we just showed a number of examples with coding. We also showed a flowchart, which isn't technically coding, but computer science has so many levels to it and so many layers to it. Coding is just one small part. Sarah also had this image in her presentation. I think it should ring a bell that this is an important visual that we're seeing it twice now. But I think this really, really clearly demonstrates coding is just this really small, maybe is not the right word, but it is. It's just a part of computer science. Computer science is a huge field. But I also want to point out this red circle here of computational thinking, which we've said a couple times here. This is a problem-solving process that helps us start to solve problems step by step, just like a computer. I love this idea about cybersecurity as well, Christine, coming in the chat for sure. I think this visual on the previous slide is probably missing a couple pieces, but exactly, cybersecurity is a huge direction that computer science is taking lately based on the ever-growing landscape of tech. So one other image we love to use is this one right here. We continuously point to this visual to talk about this idea of computational thinking. These are some of the skills that students need to be computational thinkers and ultimately computer scientists. So you'll notice skills like maybe recognizing patterns, writing an algorithm, breaking a problem down into manageable parts, creating, collaborating, and more in this visual. And I'm just wanting to pose the question, did you realize that some of these skills are all a huge part of integrating computer science into your classroom. It's not just coding. It's some of these pieces as well are just as powerful. So likely you're already maybe integrating computer science into your classroom without even realizing it. So we'll take one more pause here before we kind of shift into the why, and I pass the mic to Liz. But looking at some of the examples we've just shared, or this image of the computational thinkers, I would love to pose the question in the chat or on mute. How have you maybe already integrated computer science into your classroom? Maybe without even knowing it, maybe intentionally. I'd love to hold some space and just crowdsource a few ideas. Karen, I'm glad this poster is helpful. As I said, I feel like we use this poster in every presentation, every PD we do, because it's super helpful grounding that these are all super valuable skills to be a computer scientist or just find success in general with technology nowadays. Yeah, please, Carol, please unmute.
Thank you. Jen Wallace and I are texting in the background as we're in this session.
Oh, I love it.
Because we're both media specialists in Hopkins, and we were just saying it would be great to have, this is a little going into the weeds, but it would be great to have like an offshoot cohort of people who want to integrate computer science, but who are not classroom teachers. That is the struggle that we are having. So I'm just going to throw my email address in the chat. I don't want to sidetrack this whole thing, but if there's anybody that's interested in doing anything like that, Jen and I would love to talk to y'all, because we're going to try to do this in Hopkins. I'm a K-12 media specialist online. Jen is a K-5. I hesitated with that because our district is changing next year. She's K-5 elementary in-person media specialist, and she is on a flexible schedule, meaning the kids are not scheduled with her. Mine's a little different, so we would be open to anybody and everybody that would want to reach out, and then maybe we'll connect back with you, Ashley and Liz, to see how we might get your support to build a cohort kind of on the side.
Love it. Carol, thank you so much for dropping that plug. I definitely think part of conferences like this that make it a success is the connecting we can do. So please drop your email and a quick recap of what you said, just so that people have that in the chat. But I totally agree. I think that's a wonderful idea.
Thank
I
you.
want to highlight, I'm seeing so many things come in the chat here. I'm loving this so much. I'm not going to have time in this space to address all of them, but we'll do our best. I'm seeing an example of engineering challenges, says Christine. Fabulous idea. I think that probably tackles many of these skills here. Mark, I see your question, and I actually want to pose the tool that we're about to share in this session as a great answer to what you asked. Kathy is doing something specific with coding. Amazing. Yes, I love it. That's great. Okay, so many things. I can't read them all right now because I want to keep us on track here. But what I just want to name here is, we often, when we hear Minnesota is in last, we start to create this urgency, maybe this negativity a little bit, which there needs to be urgency. But I do think we just, as Mark posed so nicely in his question, naming for folks that you likely are already doing this, but if we're aware that we're doing it, we can be more intentional about the skills we're trying to build with students. So with that being said, I'm going to pass to Liz for a short why, if we hadn't made our case yet, for why we think you should do this, or maybe a why that you can use to bring to the teachers in your setting to say, hey, we need to do more of this or be more aware of this. So passing it over to you, Liz.
Yeah, I think that's why CS integration is so exciting, is a lot of the times we're doing it and we're not realizing it. And it can be really quick as just changing some of the vocabulary or restructuring things so that it is a more intentional integration. But I'm going to jump in really quick. As we know, like CS integration is an effective way to expand access to computer science, just because sometimes there's not capacity for a CS class or a tech specialist, and often it's on the backs of one individual. It's similar to like a grassroots movement to get it started, and taking on a whole new class just isn't feasible. But with CS integration, it makes it more approachable for teachers, because a lot of the times it's just adding or adjusting things that you're already doing, just to give it a little bit more of that intentional computer science. But yes, it increases opportunities for teachers in computer science through integration, and opportunities for students in the classroom, when a lot of these CS spaces tend to be after school or outside of the classroom. And it makes it more equitable if we're teaching these to classes that all students are a part of and have the opportunities to be in. As well as, we know computer science prepares students for opportunities outside of the classroom and in their lives beyond school. So to highlight first, like Sarah Carter had in her presentation this morning, the Minnesota standards, they're heading towards integrated standards, which means we'll all have the opportunity to start teaching these integrated lessons. And I'm going to share right now is, as I was researching for this session, I did find a document that has highlighted K-12 benchmarks that could easily be integrated with computer science already. So if there are people that are apprehensive in your networks, sharing with them that there are Minnesota standards already that they can integrate computer science into is also a great step forward, as well as to convince sometimes administrators that CS is here and we can do it and still teach to the standards. Moving on to opportunity and access. When we integrate computer science, when we have integrated classes, we allow for all students to be a part of these computer science experiences, where they don't have to be in an elective or they don't have to be a part of an outside organization. They get to be in school and get exposed to these different computer science concepts and computational thinking skills, especially if the courses aren't being offered outside of the general ed or classroom spaces. And by integrating these experiences into our content area classrooms, there are tons of benefits for all students. We guarantee that they all have the opportunity to engage with computer science and computational thinking, as well as explore some of these really cool programming tools. And additionally, we know that computational thinking concepts and approaches are problem-solving strategies that are extremely relevant in the 21st century. And if we integrate these skills into our content area classroom, students get to make these cross-curricular connections and deepen their understanding while developing computational thinking skills like perseverance, collaboration, tinkering, which are relevant in any classroom. This can also lead to increased engagement as students are preparing for their futures by engaging in a creative problem-solving process. So now I want to get to the how, because I think we're all sitting here going, this is great, but like, how do I get started? So what we've been working on is a CS integration framework, and it's a guide for educators to help them identify the computer science or computational concepts that are relevant to their subject matter. So what we do is we break it down into different steps to guide through intentionally what you're doing and how we can bring computer science into it. So our first step, this step is where teachers, and when I've done it myself, is I think about a specific lesson or unit that I want to start integrating computer science into. And I start by considering the skills that students need in this without computer science. So what do they need to know to be successful in the standard before I start integrating the computer science? And then I look for connections between the computational thinking skills. So for example, if I was teaching a lesson to kindergartners on sequencing, I would know that they would need to know beginning, middle, end, and that clearly connects with algorithms and decomposition. So creating those connections before even thinking about a CS tool ensures that we're really connecting the computer science to the academic subject matter in a way that's meaningful for learners. When a lot of times, I know myself, when I first started developing, a lot of these computer science tools are really exciting, but sometimes they don't mesh well with what we're trying to teach. And then at the end of the plan, purpose and background, we start looking at the CSTA standards to get a grounding of what standards clearly align with where I'm going. And then it is at the second stage of the integration framework is where we start thinking about if there's a tool we'd like to use, what tool we want to be using there. So we get through a whole phase of the integration framework before we're even thinking about if I want to use microbit, makey, just to ensure that we have a clear foundation of what skills students need and how we're going to get them there. Moving on for the prepping for implementation, this is a checklist just because we know that prepping changes from lesson to lesson, and it just is focusing on us thinking critically about the lesson development process and if we've created spaces for collaboration, differentiation, and opportunities for students to extend their learning. It looks, like I said earlier, very different from lesson to lesson, but it allows for the space to think critically about how we're giving students opportunities to engage with the material in a way that's both relevant and engaging to them in their needs. And then the final step of the integration framework is reflection. And I know in my lesson planning, sometimes I let this one go, but it's extremely crucial not only for reflecting on our skills that we gained throughout the lesson development process, as well as our students. And one thing that is, and we'll link the worksheet later on so you'll have access to that resource, but we really want to be intentional about what students found success in the activity and those who might not have found success in the activity, and what we can do to ensure that all students feel like they belong and have a space to engage with these computer science concepts. And I will have Ashley link in the blank worksheet so you can kind of look at the process that we went through. But our Code Savvy Educate team, when we do development, works through the integration process and collaboratively think about what CS concepts and tools integrate with what standard we're trying to connect it to. So on this slide, I have an example of a development project that we worked on where we created a second grade CS and science lesson where students learned about decision trees and conditionals and connected that to classifying animals. So we focused on those if-else statements, and students built out through an unplugged activity, a decision tree to work through it. And this is a very effective way of CS integration, which I think sometimes we can get bogged down with needing Python or feeling like we need to have Scratch, where an unplugged activity where we're restructuring something we're already doing in a way that's a little more CS focused is a really great way to integrate computer science. So I'll give you a moment to look at the worksheet, and how we have it broken up are just a series of questions that you can guide through yourself, or if you're working with someone else, to really think about and guide through this integration process. And when I've used it with teachers, it's been really effective, that first piece, to get them thinking about something they're really excited about teaching or apprehensive about teaching, and helping guide them to see the connections to computer science in that way. As you're having the chance to look through it, do we have any questions? We also welcome feedback if you think something's missing as we are working through revisions of this framework.
Just as a flag, if you're not checking the chat, we've dropped a bunch of resources in the chat. We've dropped the slide deck link. We've dropped a link to this worksheet. You'll also see this worksheet linked into our slides. But we do want to just kind of pause here and give you some chances to do what you feel like you need. We've shared a lot of information and a lot of resources.
Ashley, you're muted.
Yes, I was. You're so right. I just shared a lot of valuable information. So let me try again. No, just kidding. Okay, so we're gonna hold some space. Liz and I just shared a ton of information, a lot of resources. We have a vision for what we think a more structured approach could be to this, like 8 to 10 minutes. But we also want to just offer up, if you just want to take a look at this worksheet and read through this and think about how it might work for you or people in your context, please do that. But we envisioned here kind of for this brainstorm space for you to start thinking about how this resource might help you or your teachers is actually working through the first phase. So as Liz said, that was the purpose and background stage. So remembering at this stage, we're just starting to brainstorm lessons or units that we've maybe already taught, that we're going to be teaching, even if it's next year we're going to be teaching them, that we could be more intentional about integrating computer science into. So that's kind of our vision for how this brainstorm might work. But like I said, if you would just rather look through the worksheet and start brainstorming that way, that's totally fine. So what we provided you here was is a Jamboard that is broken down into 4 different grade bands. So we've got pre-K to 2, we've got 3 to 5, 6 to 8, 9 to 12. And you're welcome to move to the slide that feels relevant to you. So for example, we have PK2 here on the first slide, moving through, but it can be helpful to see what other folks are thinking as well, which is, if you haven't used a Jamboard, a great way to do that. So thinking about 3 questions that are actually asked in that worksheet in this first phase. So as we'd start this process, either working with other teachers or us ourselves, these would be the questions we would be asking. We would first think about what are some lessons or units that you or this group of teachers would like to integrate computer science into. We did pose kind of one example here, if that's helpful for you. The next question you might be thinking about is, what are some of the skills students would actually need to be successful in that unit? Those skills might be both content area skills and likely are also some computer science skills. And then the third question, what computational thinking concepts and approaches can you connect to this lesson? Remembering those can be as general as problem solving, collaborating, decomposition, or as detailed as I need students to know how to create a variable in Python. Just starting to really think about your own context and applying this tool to you. So what we're going to do is we're going to stop talking. We're going to play some thinking music here as we start thinking about this tool. Again, you can either use this time to look through the worksheet itself, the whole process, or you can dive into the grade band that feels relevant to you and start adding some stickies here as you start thinking about ways you might intentionally try and integrate into your own context. Definitely feel you can drop some questions in the chat, or Anne, if you want to come off mute, you're welcome to as well. I see a hand raise.
So I was just going to suggest that since we're doing this as a Jamboard, maybe we could connect our sticky note all the way across so we know which one goes with what.
Totally. I wonder how we could make that visible. What are your ideas, Anne? Like, do you mean like actually?
I'll try to put one in like that.
Okay, cool. Are you on the PK2 board, or which board are you in? 3.5.
I'll go to 3.5.
Cool. All right. I'll keep my screen here so folks can see. Yeah, you're welcome to put these sticky notes on however works for you, but I agree. We probably need to know that these are connected to each other across the row in some way. And I'm going to play some music here as we brainstorm. We want to save the last couple of minutes to kind of connect, but we'll take maybe about 5 minutes here. And I see your hand is raised. Definitely come off mute if there's anything you want to ask or share. Or maybe you forgot to put it down. I don't know. I haven't been looking.
Well, I found that it really doesn't work, but if we just do it by color, I think it'll probably read fine.
Yeah, let's stick with that for now. Let's stick with color, trying to keep ours in a kind of general row and kind of the same color. But if we get a bunch of ideas, we can just start explaining these once we open up to the group. Thanks, Anne, for your problem solving there. We'll take about 2 more minutes to do a little bit of brainstorming here, whether that is looking through the actual worksheet or if that is adding ideas to the Jamboard, whatever feels helpful to you right now. Curious, or continue to add some comments, some places for improvement in the chat. As Liz said, we're looking to create resources that feel helpful to educators, and it's best to do that by talking to you all. And would love to hold space. Anne, if you had any ideas or questions that are coming to mind as well. I recognize we could have another hour to dive into this, but unfortunately we don't have that time. We are running quite tight with our schedule here and we want to keep on track, but I'm seeing so many good ideas in these post-it notes, which I don't know about you all, but gets me super excited. I would love to just ask for maybe like one brave participant here today who would feel comfortable coming off mute and maybe sharing about one or a couple of the post-it notes that they've dropped in the board, and you can point us to which board you are working on. Feel free to raise your hand or just come off mute.
I'm working on board number 3, which is some things about generating shapes, regular polygons. And I love this lab as a way to generalize what are things common about shapes, what are the abstractions, and then could we create a little Python turtle graphics program that we would pass in one function and one parameter and draw all the shapes.
Dan, thank you. Let's give like maybe some air claps or snaps or something for our brave volunteer here, Dan. If you don't know Dan, Dan has so many wonderful contributions in the space of CS education. But I love your example here. And it reminds me that we often plug Scratch as being this visual coding platform, which it is, but Python also has that turtle application that is just as visual. So thank you, Dan, so much for sharing.
By the way, for Scratch, you can also create your own blocks. And those blocks functions, that's a really good way to teach abstraction, even at the Scratch level. So a lot of the curriculum we do for Scratch really tries to get kids to build their own blocks as soon as they can.
100%. Thank you for plugging that. Exactly. I think can be a misconception, that Scratch is just for young kids, but there are so many applications you can use in Scratch that can extend into well beyond high school age students. I appreciate that. Thanks, Dan, so much for sharing. As you see here, there's a lot of post-it notes to look through. I see, especially, I'm glad we added this last board here. Thanks for advocating for that. But to keep us on pace here, we're going to flip back to our slides and share a little bit about next steps we have for you, because we recognize we could use a lot more time to dig into this. So I'm going to pass it over to Liz.
Yes, this session was just kind of a taste of the CS integration framework, and we actually partner with schools to either provide professional development or coaching for individual teachers, grade levels, anyone that wants more support throughout the school year on how to integrate computer science or different skill developments with different CS tools. And an exciting offering we have this summer is we actually will be offering 2 different CS integration professional developments, one that will be focused on educators and the other that will be focused on coaches and administration to support in the integration of computer science. And that session will be more of a hands-on session where you'll get individual support from one of our code savvy coaches on how to build out a whole lesson or unit with the framework. So we gave you the preview of that session, but that will be happening later this summer in August. And we're really excited about that.
Awesome. Thanks, Liz, for sharing that out. And Liz attached some wonderful links in the speaker notes if you're interested in signing up or even just sharing with people in your space. We have a lot of really cool PD lined up for this summer. But with that, we're right at time. I can't believe it with everything we just shared that we're finishing on time here. But one more just view of contact information for both Liz and myself. If you have any questions, follow-up questions, want to connect. But we're just so appreciative that you all chose to join our session today, and we hope you got some valuable tools and resources out of it. And we'll pause just for a second. We're going to dive into our poster session in the 30 seconds it takes us to switch gears here, but remembering that you can feel free to turn off your camera, step away for a minute. If you need, definitely take care of yourself. But poster sessions have been switched a little bit. We're actually going to talk about the bite-sized challenge as well as our CS coaching for equity here in this poster session for the next 10 minutes. So stay here if you're interested in those projects. Otherwise, you can hop over to the other Zoom room for our other poster session, which you can see in the schedule.
Listen, Ashley, this is Rosario. I just wanted to say thank you so much. It kind of reminds me a little bit of our cohort, and especially with the poster session. So I'm like, okay, I need a little review. We all need a little review. So this is very helpful. So thank you so much, ladies. And Kathy, it's always good to see you too. Just kind of getting the band back together, right? The cohort.
Totally.
Or expanding the cohort, I should say.
Yes. Miss Rosario, we're so happy you came today. It's so good to see you. I'm happy this was helpful.
It
Always
is very helpful.
appreciative.
Yes, thank you. No, it's it's like being at home, and I don't really say that lightly either, because
Yeah.
very few places are like home. And it's physically I am at home, but
Yeah.
but no, the camaraderie. I don't know how to say that word in English, but I thank you, Dan. My backup. Um, but no, I really like it. I just it's and you know what I really like. I don't have that big science background. I have more the accounting business background, but I understand everything you present, and I love that because I'm like, okay, I don't feel like I'm lost. I can follow it. I can explain it, because sometimes I go to sessions, professional sessions, anywhere, even on education, and that's my field. I have a master's, and I'm like, okay, you've lost me. I'm like,
Miss Rosario, you're kind of making us blush here, I think. You're
No.
always here for the love. We're always
I was going to say the same thing though, because I just told my husband, like a lot of it, especially like the computer science and stuff, that's what we do in our PLC. And I'm working on my integrated unit right now. And I just said, a lot of it
Yes.
is just review, but it's reinforcement. And it just reminds you to bring those practices back into your classroom.
Yeah, I'd love to plug for those that don't know Kathy and don't know Miss Rosario here. These are both current cohort members, which we're gonna plug the cohort in our ending session, but both of we have a couple others here in this space as well.
Yes.
Just have been so grateful for all of your contributions.
I actually had like this big breakthrough because I sat down and started filling all the things out for my coding cohort, my coding
Yes.
unit. And you know how you have a task and you have to break it down. And it's like I started doing it and it was like I had this sense of relief, like now I'm going to put it into practice and see how the kids, because I've been working on the bite-sized challenge too. And
Yes.
it's like getting to the end and it's like, oh my gosh, this is so exciting to actually see
Yay.
in action and like using the lessons and using the words and just, I don't know, I'm like Rosario. It's just made me feel really, really more better about my own teaching this year.
Yay, Kathy, we're so excited. That's such positive feedback. And you totally transitioned us into, we're actually going to talk about the bite size challenge in this poster session here. So thank you both so much for your kind words. We're so happy to be savvy.
I did run into some constraints and I, explained to Val some of the things with our snow days and stuff. But the most important is the equity piece, because we are giving that opportunity to our students. And I actually have students who are so excited. And I think of your girls who code and some of the kids who come in and they're like, they just take off on it. And then I found out in the 6th grade, they have it as an elective. So our 4th graders have actually been prepared for future learning, and they have this opportunity. Even if we haven't been able to get through the challenge like we wanted to, we actually had, I heard your guys's voice saying, just do what you can, because
for sure
actually have some exposure for what they haven't had before.
Totally agree. Thank you, Kathy, for that input. I'm glad the flexible nature of it has been so helpful. I would love, Kathy, as we're kind of explaining this bite-sized challenge to the group here, if there's any input you want to just drop in the chat to share with folks. We're so lucky that somebody who's actually teaching it is here in our space today. So definitely add some more thoughts in the chat if we're missing something. I did just drop in the chat for folks here for our poster a link. We're going to try and tackle kind of 2 pieces. We might not finish them both, but we're going to give you've got the resource if you want to go back and watch some of these videos. But the first is I'm going to pass to Brad to talk about our coaching for equity piece here, which might be new to folks here. So Brad, I'll pass the mic over to you.
All right. I'm the push right now on this slide where it says CFE presentation. Please, if you have the time, go through that. My colleague and friend Andrea Wilson Vasquez did an awesome job of doing a guided version of the slideshow. So just quick elevator pitch here for Coaching for Equity. This is a National Science Foundation funded project. And our goal is to train coaches that are able to connect with 2 coachees throughout the school year and do our best to improve their equitable pedagogy in their classes. So yeah, like I said, all the details are in that link there. If you go through that, but we're looking for, in particular, high school classes. So there's 2 different parts of the project, and the Code Savvy part is focused on just Minnesota. And you have to be a high school teacher of computer science. The nice part about that is any type of a class. If it's integrating computer science into a science classroom, that still counts. You know, you're still eligible. Unfortunately, right now, it doesn't focus on the pre-K through 6, but or up through 8, sorry. But we're kind of looking at possibly going for a grant to do that in the next section. So this one is just for high school teachers. So please reach out if you have any questions. But again, the link on that slide, the CFE presentation, Andrea does a spectacular job of giving you all the details.
Thanks so much, Brad. Brad, if you feel comfortable with it, just looking at our time, I think so that we can make sure we give some context for both of these projects. We've got the link in the chat for folks to watch the video on their own if you're interested, but a really, really incredible opportunity for high school educators, as Brad mentioned here. And the other one that you heard through Kathy was kind of alluding to this piece. Oop, here we go. Here we go, is the bite size challenge. And I just recognize I tried to add a lot of resources here on the slide here quick this morning, and this is a little bit of a busy slide. So let me just name a bunch of pieces here. But as Val presented in our opening session, Code Savvy is trying to ensure that everybody has access in our state to computer science. So our Code Savvy Experience program has started creating some of these longer form curriculums that teachers can take and use in whatever space feels best for them. Some teachers are using this in after school programs, some are using this over the summer, some are using this during a computer science class or during a tech class. We have media specialists teaching this curriculum, but we're here to talk to you just about the Bite Size Challenge here today, which is a curriculum of 16 40-minute lessons. And this curriculum teaches students how to use the microbit to solve a global goal or a global problem that they're passionate about. So in addition to obviously gaining skills with the microbit, students are learning how to use creative coding. They're getting lessons in problem solving, user experience, if you're not familiar with that word, or design thinking, but thinking about creating technology for a specific user. And gaining presentation skills and confidence throughout the process. So as students, they're not only creating, but they're actually making a pitch at the end of these 16 lessons to share the whole process of their experience here. As Kathy mentioned as well, this curriculum is flexible and can be delivered as you need. So as I said, in an after school space, during class, during a span of 2 weeks, if you want to do a quick crunch or crash course, I guess, if you will, of this curriculum, you can. Over the course of a whole semester, if you prefer, maybe a lesson a week. We want this curriculum to work for you and your students. So a little bit more context, we provide the curriculum and the hardware, the microbits. We provide mentors, we provide snacks. We ask teachers to provide the classroom oversight, the guidance, the laptops, the Chromebooks, and of course, most importantly, the relationships with your students. So we've got this video here if you want to learn more, but I do have a link to a blog post if you want to read more about this. If you have specific questions and want to get involved, you can reach out to Val, whose email is in this slide as well. We are looking for Minnesota educators who actually want to lead it, so a link to sign up, but we're also looking for industry mentors who want to support classrooms and support students inside classrooms. So we've got a link for that as well.